In this video, we're going to look at Descartes' Rule of Signs. Now, this rule is used to check and see how many real zeros a polynomial has. And we do that by looking at the number of possible positive real zeros and the number of possible negative real zeros. Make sure your polynomial has the terms in descending order. Look at the signs of p of x. So if you just look at the function as is, the number of sign changes tells you the number of possible positive real zeros that may exist. It's either that number or less than this by an even number. When you plug in a negative x and simplify for it, the number of sign changes tells you the possible number of negative real zeros by that number or less than that by an even value. And so that's just like the gist of Descartes' Rule of Signs. To understand it, let's look at some examples for it. So we'll break it down step by step. If I'm given my polynomial 4x to the fifth plus 3x to the fourth minus 2x cubed plus 5x squared minus 6x plus 1, all my exponents are in descending order, so that takes care of that. To find the possible number of real positive real zeros, what I want to do is I want to look at the sign changes as is. We want to figure out, how many sign changes. So I just take a look. The first one's positive, so a positive to a positive, no sign change. Positive to a negative, there's a sign change. Negative to a positive, there's a sign change. Positive to a negative, there's another sign change. Negative to a positive, another sign change. So there are 4 sign changes that occur with p of x. That tells me I have a possibility of 4 positive real zeros. And this is a possibility. It's that number, or it is that number subtracted by an even number, which, subtract 2 for this. So if I subtract 2, I could also, it's 4 positive zeros, or it's 2 positive real zeros. Or continue down, you could have 0 positive real zeros. And that's what it means in Descartes' rule when it says same as the number of sign changes or less than this by an even number. We are subtracting 2 to figure out what our other possibilities are for this. So this is the possible number of positive real zeros are 4, 2, or 0. Now for the possible number of negative real zeros, what we do is we plug in negative x for x. So my function now turns into 4, instead of x to the fifth, I have negative x to the fifth, plus 3 negative x to the fourth, minus 2 negative x cubed, plus 5x squared, so instead of x squared, it's negative x squared, minus 6 times negative x plus 1, and I have to simplify. A negative to an odd power is always going to be negative. And so I have here a positive 4 times a negative is a negative 4 x to the fifth. A negative to an even is always going to be positive. So positive 3 and a positive is a positive 3 x to the fourth. A negative to an odd, that means this one is going to be negative. So negative 2 and a negative is a positive 2. Negative to an even is positive, so positive 5 and a positive is a positive 5. Negative 6 and negative x is positive 6x plus 1. And again, we look for, just like we did before, the number of sign changes that occurs. So for the number of sign changes that occurs, Let's take a look. We go from a negative to a positive. So that's one sign change. Next one's a positive to a positive, no sign change. Positive to a positive, no sign change, no sign change. Positive, positive, no sign change. So we have one sign change. So that means we have a possibility of one negative real zero. Now we can't go less than this number by an even, because if I do, I get into negative number of real zeros, and you can't have a negative number of, x intercepts. You have to have a positive or none. And so since you go into the negatives, if you go less than an even number by that, you don't do it. And so my number of possible negative real zeros is 1 for this. And so that's how Descartes' rule works. Let's look at another example. So when you state the possible number of positive real zeros, you just leave it alone as is and look for your sign changes. Positive to a positive, positive to a positive, no. Positive to a negative, yes. Negative to a negative, no. And so I have one sign change, which means I have a possibility of one positive real zero. And so we do the same thing for p of negative x here. And so I have to rewrite my polynomial. And this time put a negative x. So I have negative x to the fourth plus negative x cubed plus 2 times negative x squared minus 3 times negative x minus 1. Negative x to the fourth is positive x to the fourth. A negative to an odd power is negative. So positive and negative is a negative. So I have negative x cubed. Negative to an even is positive. So positive 2 and a positive is a positive 2x squared. Negative and negative is positive 3x minus 1. And we count the number of sign changes. So I go from positive to a negative, yes, that's a sign change. Negative to a positive, yes, that's a sign change. Positive to a positive, no. Positive to a negative, yes. So I have 3 sign changes. Which means I have a possibility of 3 negative real zeros, or less than this by an even number, or 1 negative real zero. So the possible number of positive real zeros is 1. We can't go less than that by an even because we get into the negatives. The possible number of negative real zeros is 3 or 1. And we'll try this one last time. And this one's really cool. State the number of positive real zeros. So let's look at our sign changes. Positive to positive, none. No sign change. There's the sign change. We have one sign change. So that means we have one positive, a possibility of one positive real zero. Now we do it with our negative x plugged in. So I have negative x to the fourth plus 7 times negative x squared plus 3 times negative x minus 9. A negative to an even power is positive, so I have positive x to the fourth. Negative to an even is positive, so positive 7 times positive is positive 7. Positive and negative is negative, and negative 9. And we look for the number of sign changes. Positive, positive, nope. Positive to negative, there's a sign change, and negative to negative, no. And so I have one sign change. That means I have a possibility of one negative real zero. Now I said this is the interesting one. This is the cool one. Look at your degree. This is why this one's cool. Your degree is 4. You're supposed to have 4 total zeros, but I have a possibility of 1 positive real zero and 1 negative real zero, which means if I'm supposed to have a total of 4 zeros, 4 total zeros, that means you have 4 total zeros which are real or imaginary. Right now, I'm only accounting for 2 of them, a possibility of 1 positive and 1 negative. So I'm actually subtracting 2 from that. So how many imaginary zeros do I have here? I'm going to have 2 imaginary zeros. Now that's cool. I can see my positives and my real zeros don't add up to my possibilities. I'm still missing 2 of them, which means I know my other ones have to be imaginary. So in Descartes' rule of signs, you keep it as is and look for the sign changes. That's going to tell you the possibility of the number of positive real zeros. When you change x to negative x and simplify from there, those sign changes tells you the possible negative real zeros, the amount of those. And that is Descartes' rule of signs.